Hey guys, Mr. T here. This is another video. This one is on similar figures and similar triangles. So before we start on the topic of geometry, we need to have some understanding of the idea of similarity in shapes. So two figures, that's the mathematical word for shapes, are similar in maths if, number one, the figures are equiangular. That means that all of the angles in the figure are equal. And two, that the corresponding side lengths are in the same ratio. And what that means is that a comparison between two sides, so if you made a fraction out of two of the sides, put one length of one side on the top of a fraction and another side length on the bottom of the fraction, if that fraction in the first shape makes the same fraction or the same number when you make a fraction or the same comparison in the second shape, they're similar. So if the two fractions are equal between the two shapes, then they're similar. So we'll show that in action down here. We've got four shapes here. I want to compare to shape 1. So you've got this this four-sided shape, sides 2, 3, and 3, and 5. So this smaller shape here, it looks like the angles might be the same, but if I grab, if I number this side 1, 2, 3, and 4, side 1 over 2 in shape 1 is 3 on 5. And if I do the same fraction on the corresponding side, so 1 and 2 on shape 2, is 2 and 4, they're not equal. So so that's 1 on 2, and this is 1 on 2 as well. They're not equal, so they're not similar. Alright, let's compare shape 1 to shape 3. Here you can tell that the angles are nowhere near the same. This angle is not anywhere near that angle. This is completely the opposite kind of angle. This here is different angle, and lastly that last corner, so angles not equal. So that's the other way that things cannot be similar. So this last one here, the angles look about right. Yeah, it's not the greatest drawing, but I didn't draw it with a ruler. So if I write the corresponding angle, the corresponding side numbers here, if I make a fraction out of that 1 over 2, that would be 6 on 10. What does that cancel down to? Well, 2 goes into both of these, it cancels down to 3 on 5. So you'll see that the corresponding sides form similar ratios, so shape 1 and 4 are similar. They have the same angles and they have the same ratio between corresponding sides. So this is important for us because we're going to be using that for using that with similar triangles. So you're going to do a lot of work using the similarity in triangles. Like if you only need to prove one of the two things below to know that two triangles are similar. So two triangles are similar if you can prove that they have the same angles. And another thing is that you only need to prove two are the same. And the other way to prove if triangles are similar is if their side lengths are in the same ratio, so the same process that we did up here. If you can prove that, two of the same sides form in different triangles form the same ratio, then they're similar. Or if they've got the same angles in the two triangles, they're similar. The little star here is to help is an extra thing because the angles in a triangle always add up to 180 degrees. If you know two angles are the same, then the last angle is going to be the same too. So you don't actually have to prove all three angles are the same. You only need to prove two are the same. So let's see how this works, proving similar triangles. Show that the figure below contains two similar triangles. So we have a large triangle and a small one there. So let's mark angle A, B, and C is equal to angle D, B, E because they are the same angle. That's the same angle in both of these triangles. That angle forms the bottom of this small triangle. It also forms the bottom of this larger triangle. So we've proved one angle is the same. Now, these two lines are parallel, so they go straight in line with each other. If you draw a line straight through them, okay, this angle here, that's blue dot, and this angle here will be exactly the same angle. So angle BED is going to be equal to angle BCA, because they're corresponding angles. You won't need to go too much into these wordings here because we're not doing that in the topic, but that's the reasoning behind why those angles are the same. And now we've proven two angles are the same in the two triangles. Angle CAB is going to be equal to angle EDB, so the last one left over here, they'll be equal because angles in a triangle add up to 180. We already proved two were the same, so the leftover one is going to be the same. So these two triangles, therefore triangle ABC is similar to triangle DBE, because we've proven that three angles are the same. Next one. So this next diagram, I've accidentally put the given angle in the wrong place. It's actually here. So this next diagram, alpha is equal to angle STR, this one here. Angle STR is equal to angle PQR as given, because the diagram gives it to you. I mistakenly put it in here, but that's okay. That gives it that's the next step anyway. So STR, PQR are given. We've proven two angles are the same. Now these two, the ones that I crossed out, we'll call that blue dot. Angle SRT is going to be equal to angle PRQ, because these are straight lines here. And if you cross them over, the angles opposite from each other will be equal. And the wording for that is vertically opposite. So those angles are going to be the same because they're vertically opposite from each other. So lastly, angle RST is going to be equal to angle RPQ, the last one left over, because of angles in a triangle are 180 degrees. So we already proved these two were equal. The last one is left over. It has to be the same. So therefore, triangle PRQ is similar to triangle SRT. So that's just giving you a taste, a little bit of an idea of how you prove triangles are similar. We're not doing the geometric reasoning topic in full here to understand what is meant by vertically opposite and other ways to prove that angles are the same. We're just going to be using often that the triangles are similar. So this is just to give you a little taste of some of the things we'll need for the topic that's coming. Hopefully that helps you out, and I'll see you in the next video.